All right, goal for today is to find the area of circles, sectors, and segments of circles. Lots of S's and C sounds right there. Area of a circle is what we're going to start with. An area of a circle should actually be review for you guys. You guys have covered it before. So if you remember, area of a circle is pi radius squared. Okay, so when we look at this first example here, right, they give us the radius. So I'm going to take pi times 7.6 squared. And on my calculator, pi times 7.6 squared, I end up with 181.46, and I'm going to label it meters squared. Make sure you're labeling your answers for area and it's in units squared. Okay, next example is just an algebra example, and it says the area of the circle is 196 pi square yards. Find the diameter. So I take my area of a circle formula, which is that pi r squared, and I'm going to take this area and plug it in for a. So I get 196 pi equal to pi times the radius squared. When I divide by pi on both sides, what's really going to happen is all the pi's cancel out, and now I have 196 is equal to the radius squared. Last step, take the square root of both sides. We find the radius is equal to 14, but we haven't answered the question because they want to know the diameter. So if I take the radius times 2, that gives me the diameter. So my final answer is 18 yards. Okay, once again, focus on labeling. Okay, next one is a vocab term, and the vocab term is a sector, and a sector is just a region that's bound by the central angle and its arc. So if we look at this diagram right here, what they give us is that central angle, and then here's our arc. So the sector is this space that's inside. It's just like a section of the circle. So it's a fractional part of the circle. So what I can think for my fraction is that angle over 360, which is the whole circle, times pi r squared, because once again, we're finding area. Okay, if we look at the example problem on the next page, we say that fraction, so the angle over 360, 120 over 360 times pi, what's our radius? 5 squared. So if I go 120 over 360 times pi 5 squared, I end up with 26.179, so I'm going to round it to 26.18 centimeters squared. Okay, so area of the sector. Last vocab term for today is called a segment. Okay, and a segment is a region that's bound by the chord and its arc. Okay, so if I look here, we have that central angle still, that angle CAB as the central angle. And then what they did is they drew in this chord right here, and this little piece right here is called the segment. Okay, if you think of like a slice of pizza, the segment would kind of represent like the crust on that slice of pizza. In order to find the area of the segment, there's multiple steps to it. We are going to start with the area of the sector, which we found on the last page. Subtract out the area of this triangle right here. Okay, so subtract the triangle, and what would be left over is the area of the segment. And that's going to be our method for solving on the next couple problems. So the sector minus the triangle equals the segment. Okay, this first example right here, find the area of the shaded segment. So I'm going to first by finding the area of the sector. Area of the sector, I take my angle, which is 120 over 360, and then I need to multiply times pi radius. Radius is 6 in this problem, pi 6 squared. Okay, so if I calculate 120 over 360 times pi 6 squared, I end up with 37.699, so I'm going to round it to 0.8, 37.8, and we can just label it units squared for right now. Next would be the area of the triangle. And area of a triangle, we go base times height divided by 2. The one thing that's really great about this section is we've actually worked with these triangles before when we found the area of regular polygons. So I have this angle right here, which is 120. That's that central angle. I can draw in the radius on each side. What we did before was we dropped in this segment right here. It's called the altitude. When we worked with the regular polygons, it was called an apothem, but it's an altitude on the triangle. So when I sketch out that right triangle for you, what happens is this radius still remains 6. This top angle is now going to be 60, and now we see 60, 90, this has to be 30. So we can use those special right triangle rules. If I'm given the hypotenuse, I take the hypotenuse and divide by 2, which gives me 3. 3 is going to be the short leg, so across from the 30 is going to be 3. To get the long leg, I take 3 times the square root of 3, and that's 3 root 3. So when I go back to my original triangle, the one that we're actually finding the area of, the height is 3. This segment is 3 root 3. This segment over here would also be 3 root 3, which means the full base will be 6 root 3. And now we can calculate the area of the triangle. So 6 root 3 times the height divided by 2. What we're going to do today, usually we leave it in radical form, but since our first answer is already a decimal, and we're going to have to subtract the two values, we're going to actually calculate this and get a decimal answer as well. I ended up with 15.588, so I'm going to round it to 15.59 units squared. And then my last step here is I'm just going to subtract them, because really what I want to find is the area of the segment. And if I take this full sector over here, the full sector, and I cut out this triangle, what's left over is this segment, and that's what we're finding the area of. So if I subtract them, 37.8 minus my 15.59, I end up with 22.21 units squared, and there's the area of the segment. Okay, now this example was nice because it had special right triangles, but I want to walk you through one that doesn't use special right triangles. Okay, and you guys are going to get some review of trig functions using this type of problem. Okay, so method is the same in that I'm going to start with the area of the sector. Okay, area of the sector, I take that central angle over 360, so the fractional part of the area. To calculate area, remember we go pi r squared, so pi 12 squared. Okay, so 140 divided by 360 times pi 12 squared. I end up with 175.929, so I'm going to go 0.93 units squared. Next, I'm going to calculate the area of the triangle. Okay, so for area of the triangle, remember we go base times height divided by 2, and we're going to have a little bit more workspace here, okay? So if I draw out that triangle, I know the top angle here is 140, and each radius is going to measure 12. We're going to draw in the the altitude. That was not a good thing to say. It's the altitude. Okay, this is going to be 70 here. This is our 90, and then the side length is 12. So I'm going to find this side first, and what I need to use is my trig function. So from this angle, this side is adjacent. This side is the hypotenuse. I'm going to use ka, which is cosine. So I say cosine of 70 is equal to adjacent over hypotenuse, so x over 12. To solve here, we cross multiply. I'm going to get 12 cosine of 70, and that's going to give me the x value. So if I go 12 times the cosine of 70, I end up with 0.1 for my height. And I can fill it in over here as 4.1 also. Okay, I'm going to call the bottom piece y, and from this angle, the 70, this is considered the opposite, and then I have the hypotenuse. So this time I'm going to use which is sine of 70, is equal to the opposite over the hypotenuse. Okay, cross multiply once again, I get 12 times the sine of 70. And if I go 12 sine of 70, I end up with 11.28. Okay, now 11.28 is going to be this bottom piece, but it's also over here. So when I want to calculate the full base of this triangle, I need 11.28 plus 11.28, which gives me 22.56. Okay, so the base is 22.56 times the height, which was 4.1, and then I divide by 2. And my area is 46.25 units squared. The last step I need to do is find the area of the segment. So the area of the segment is found by subtracting that triangle from the sector. So if I go 175.93 and I subtract the 46.25, I'm left with 129.68 units squared, and that would be the area of my segment. Okay. Last problem is just going to review how to find the area of the sector, which we did on each page, but it's saying find the area of the shaded region. Some students will look at this and not think that it's a sector, but remember, it's just the region that's bounded by the arc, okay? So what I can do is I can find the measure of this angle right here by taking 360 and subtracting the 65. It's going to leave me with 295. Now I'm going to go 295 over 360 times the area of the circle, which would be pi r squared, so pi 11 squared. And 295 out of 360 times pi 11 squared, I end up with 311.497. So I'm going to round it to 311.5 inches squared. Okay. For today, you guys are going to have a worksheet. It's called Area of Circles, Sectors, and Segments. It is on Google Classroom. It is also on the Accelerated Geometry website for class under the Worksheets tab. If you guys have any questions, feel free to email me and I'll get back to you. Thank you. I'll see you later. Bye.